logarithmic equations and applications. Our objective here, we want to solve equations and applications involving logarithmic functions. And as you might imagine, when we saw in our previous video that exponential functions and logarithmic functions are related, we're going to use exponential functions to do this solving. So let's come in. What do we know? We know what an exponential function is. Any function of the form y equals b to the x, b is the base, where the base is positive but not equal to 1, and x, the exponent, is any real number. We also know what a logarithmic function is. Any function of the form y equals log base b of x, where the base b is positive and not equal to 1, and x for the log function is also positive. As a reminder, the number x is called the argument in the log function. The log function outputs an exponent, which is why it can be used to solve exponential equations in which the variable is the exponent, because the log will tell us the exponent. The exponential function and the log function are related. Y equals b to the x, the exponential function, is equivalent to x is equal to the log base b of y. The log, again, outputs the exponent. Alrighty, let's do some examples of what this is all about. Okay, if given with an unknown base, if given a log equation with an unknown base or argument, one way to solve it is to rewrite it in its exponential form. Okay, a quick note here. You may need to isolate the log term first before rewriting. So here is a log equation that we want to figure out. What's the argument? Okay, well, what do we know? We know the log base b of y is an exponent, and that is equivalent to the y is equal to b to the x. So here we're looking for the argument. Well, we can use the exponential function to find the argument. Okay, so we have the log base 6 of x is equal to 3. And as we noted with exponential functions, base to exponent equals argument. This can be rewritten as 6 to the third is equal to x. Well, we can solve 6 to the third with a calculator. 6 to the third turns out to be 216. So what this is telling us is the log base 6 of 216 is 3. And of course we can check that with a calculator. What is the log base 6 of 216? And we can come into our calculator and we can say, all right, what's the log base 6 of 216? Back into functions, choose our log variable base. Log base 6, the argument we said we came up with the answer of 216, and sure enough, it gave us 3. So we know that our argument of 216 is correct. Okay, so we just did, whoops, I should first adjust this. So we just did that check right there with our calculator. Okay, let's take a look at one here in which we are looking to find the base. Okay, so let me get straightened out here. So solve log of base b of 4 is equal to 1/2. So what number to the 1/2 power is equal to 4? Well, again, we know that this statement, log base b of y is equal to x, is equivalent to b to the x is equal to y. Okay, so let's write ours in here. We have a log base b of 4 is equal to 1/2. One equation and one unknown. We want to solve for the base, so we know The base to the exponent 1/2 will give us 4. So this becomes b to the 1/2 power is equal to 4. Okay, well, if I square both sides, I will undo that square root. And we come up with b is equal to 16. And again, we can check this. Okay, we're saying the base is 16. So is the log base 16 of 4 equal to 1/2? Put that into your calculator, and you'll come up with the fact that indeed the log base 16 of 4 is equal to 1/2. All right, let's take a look at another example, a couple more examples actually. One that's an application example, and one that involves an extra step because the log is not isolated. So we want to solve this one. It says solve 4 times the log base 8 of an argument that is n plus 1 equals 12. So we want to solve this one for n. Okay, that's in the argument, so we can use its exponential form. But first, let's get the log by itself. So let's first take this 4 log base 8 of the argument n plus 1 equals 12, and let's divide both sides by 4 to get the log by itself. Well, 4 divided by 4, of course, is 1. I made my 1 there. And so we have on the left side, log base 8 of n plus 1 is equal to 3. And now we say, okay, well, I have a log function here. I can rewrite it in an exponential form. 8 to the 3rd power is equal to n plus 1. Okay, 8 to the 3rd power is equal to n plus 1. Well, that's not too bad. 8 to the 3rd power, I'm not sure what that is. Let's just subtract 1 from both sides. N is equal to 8 to the 3rd power minus 1. Okay, that goes into a calculator. 8 to the 3rd power must be 512. And this comes out to be 511. Okay, and again, we can check this with our calculator and our log function. Does 4 times log to the base of 8 of 511 plus 1. I put my n in up here. Does that equal 12? Into a calculator this goes, out comes 12, and we're good. So this one required first isolating the log term. Okay, we got to get that 4 moved out of the way so that we can rewrite it in its exponential form. Okay, our final example here, number 4, has a bit more of a real-world look to it. The velocity v of a rocket when its fuel is completely burned is given by the equation v is equal to u times the log base e of w sub 0 divided by w, where u is the exhaust velocity, w sub 0 is the liftoff weight, and w is the burnout weight. Solve for w. Okay, let's see here. V is equal to u times the log base e of w sub 0 over w. Okay, so we want to solve for this w right here. Well, let's first, before we can rewrite it in an exponential form, let's move this u over so we can do that. So I'm going to divide both sides by u. And that, of course, is u divided by u is 1. I'll divide this by u. And I'm going to write the log on the left side, the log base e of w sub 0 over w is equal to v divided by u. Well, that's good. I got the u out of the way. Now I can rewrite this as an exponential function. Okay, so e to the exponent v over u. Yes, it's a fraction. Don't let that get you excited. It's just an exponent. Is equal to w sub 0 over w. Okay, now a little bit. I'm looking for w, and it's in the denominator. So let's first multiply both sides times w so I get it out of the denominator. And I have on the left w times e to the v over u exponent is equal to w sub 0, because w sub 0 over w times w is w sub 0. Well, that's nicer. Now I've got w here out of a denominator. I need to solve for it. So I'll divide both sides by e to the v over u, because it's multiplication. So e to the v over u. Of course, that's a 1. And I come up with w is equal to w sub 0 over e to the v over u. Certainly it doesn't look very pretty, but it doesn't matter. That's the answer. You might want it. You also can consider, because this is kind of a little bit of a messier fraction, you can write this as, if you want to move the exponent term into the numerator, we just negate it to use the inverse. So this is the same as w sub u times e to the negative v over u. Same thing. This one, of course, has a positive exponent, but it's within a fraction. This one has a negative exponent, but it's not within a fraction. So there you go, a fair amount of work with logarithmic equations and applications, making use of the fact that we can change it into its exponential form to solve for bases and arguments.